The last thing we're going to talk about is just building on this idea of significant figures and a couple of terms that we use in science to talk about values or measurements that we make. And these terms are precision and accuracy. And these have very specific meanings when we're talking in science. And so let's talk about this in the analogy of a dartboard. This is an analogy that I was taught as a student, and I think is a really nice one that works. So with the dartboard, there's a specific spot you're aiming for. That's the bullseye, right? You would like to hit the right in the middle to get the most points. And so that is your target that you're aiming for. And in the example of a measurement, a chemical measurement, say you're using a balance or whatever, that would represent whatever the true value is of the thing you're trying to measure. So say it's the exact mass of the powder that you're weighing, or it's the exact length of the piece of paper that you're looking at, or the exact volume of liquid that you have that you're doing for some measurement. And so ideally, we want our measurements to give that value exactly the same every single time. And so that would be an example of precision. So let's talk about precision first. So precision is measurements are repeatable. In the case of our dartboard example, that would mean that every time we throw the dart, it lands in the same spot. Now, it doesn't necessarily tell us whether that spot is the bullseye, right? So precision just tells us that something is this, you get very close to the same result every single time you do it. So as an example, let's look at these pictures. If we look at number 2 here, this dartboard here, this is an example of, say, a measurement that's very precise. It's landing right here on this red square pretty much every time, very close to each other. All the darts are very, very precise. We're getting the same thing every time. But the true value is down here. Let me use a better color here. I think red might show up better. Right, the true value is over here at the bullseye. So this is an example of something that is precise but not accurate. So when we use the term accurate in terms of scientific measurements, what we're saying is that it gives the true value. Accuracy tells you how close to the true value your measurements are. Or we could say the measurement is correct, right? It gives the actual value. Okay, in our case, that means how close is it to the bullseye? Right, if we go to our example on the far right, we have an example that has neither of these things, right? So the darts are landing in different spaces spread all around, so not precise. So the measurements are not very repeatable. The person throwing these darts is not very good, right? They're just sort of throwing them randomly, and they're hitting in different spots on the dartboard. And they're also not accurate. Oh, you can't see that. Let me scroll this down a little bit. So not precise, also not accurate. So, and because all of these are really far away from the bullseye. Ideally, we want something that's like our dartboard on the left, where all the darts are grouped together pretty well, and they're grouped together around the center of our dartboard, meaning that the measurement's correct and it gives the same value every single time. So this is the ideal. We want something like this, where this is precise and accurate. Sometimes this happens, right, where you do your measurements and you get the same result every time, but there's some sort of error causing you to miss from the true value. And what you really don't want is this last one, where your answers are not the same every time and they're never correct. Makes it a really not very useful measurement. And so when we talk about these ideas of precision and accuracy, and you'll talk about this in your lab especially, this is what we mean by that specifically in science.